Okay, so we'll give this a go. So this is lesson 33. This is the second one since Corona put us all in our houses. So in theory, you have seen this worksheet. If you have not seen this worksheet, go into Canvas, grab the worksheet, do the questions. It does not help if you just watch me do this unless you have tried to do this. But once you have tried to do this and you want to see if you are right, then you check in with me and we talk about how this goes. So I'm going to try to answer some of these questions. The questions on the front side of the sheet were screenshots from previous year's exams, so you can get a sense of the kind of thing we're going to have to do when we're on our own. So here we go. There's the wall, and a 10-foot ladder is leaning against the wall. I don't have to label it with a variable because the ladder is always 10 feet long. So then a man pulls out the bottom of the ladder at a constant rate of 2 feet per second. There is a constant rate of 2 feet per second. But what's increasing? Like something's increasing over time at 2 feet per second. Well, this distance is increasing at 2 feet per second. So that distance is increasing at 2 feet per second. How fast is the top of the ladder going down the wall? So that means we're looking for the rate of change of some other quantity with respect to time. There's the top of the ladder. It's going down, which means that this vertical distance is decreasing at 2 feet per second. So the top of the ladder is going down the wall when the base of the ladder is 6 feet from the base of the wall. So this is changing, this is changing. The ladder is always 10 feet long. So x squared plus y squared is 10 squared. So we take derivatives on both sides with respect to time. The derivative of x squared is 2x. X is not time. The derivative of y squared is 2y. Y is not time. The derivative of 100 is 0. So now everybody gets substituted. I mean, the 2's can go because we can factor out a 2 and divide. So now the base of the ladder is 6 feet from the base of the wall. We know what dx dt is. At this special moment in time, base of the ladder is 6 feet from the wall. The ladder's 10 feet long, so the top of the ladder is 8 feet up the wall. We're looking for dy dt. So how do we find dy dt? We kick that over to the other side and divide by 8. This is negative 1.5 feet per second. How fast is the top of the ladder going down the wall? So it's important to say this. dy dt is negative 1.5 feet per second. So how fast is the top of the ladder moving down the wall? The top of the ladder is moving down the wall at 1.5 feet per second. The answer to the question is 1.5 feet per second because the question is already assumed that the top of the ladder is going down the wall. All right, so we'll see what's happening over here. A square is projected. That's the side of the square, so that its area is increasing. Its area is increasing at the rate of 12 square inches per second. At what rate is the side of the square increasing? This is the thing we're looking for when the area is 100 square inches. So we know that the area of a square is side squared. We take the derivative of both sides with respect to time. We take the derivative of both sides with respect to time. We know what this is. We want to know what this is. So what's that? When the area is 100 square inches. When the area is 100 square inches. Okay. If the area is 100 square inches, then a side is 10. And so this is 12 over 20. And that's 0.6 inches per second. 0.6. 0.6 sounds about right. Sounds about right. That question went well when it was given. I was glad for that. Let's do a little physics for all our physics. We don't have a physics major in our class. What in the world was I thinking here? So the voltage and the current and the resistance are all related this way. So we're going to assume that V is increasing at the rate of 1 volt per second, which means that voltage is increasing, right? And then I is decreasing. So I is changing over time, but that's negative. The pen is slow. So we want to find the rate at which R is changing. We're looking for the rate at which R is changing. We want to find the rate at which R is changing. So what does this all mean? So we start with this. That's the relationship among the variables. And then we take the derivatives on both sides with respect to time. The derivative on this side with respect to time, straightforward. This is a product rule. The product rule is so much fun. It's 1 times the derivative of the other plus the other times the derivative of the one. So what is all of this? That's 1. They told us I is 2. dr dt is the thing we're looking for. They told us that they didn't tell us what R was. They didn't tell us what R was, but they told us what V was and what I was, so R's gotta be 6. And they told us that di dt was that number, and so 1 is equal to 2 dr dt minus 2, and that means that dr dt is, kick this over, divide by 2, 3 halves ohms per second. R is changing at 1.5 ohms per second. Is R increasing or decreasing? R is increasing because that's a positive number. Okay, those are 3 related rates questions that you should be able to do on your own. So I'm going to hit the pause button. I'm going to let this post to YouTube. Then I'm going to record the linear approximations part of this because that's separate. Thanks so much.